Hi, grade 9s. Welcome to Exponent Laws, the first Exponent Laws section, which is 2.4 in your workbooks and in the textbook. Patterns arise when we multiply and divide powers with the same base. So mostly when we're doing exponent laws, we're probably dealing with multiplication and division of powers. We did addition and subtraction in 2.3, so I think we've got those covered. Now we're looking at multiplication and division. So for instance, let's say if we're going to multiply -7 to the power of 3 by -7 to the power of 5, if the integer base is the same, in this case it is -7 and -7, those are our bases, we can actually do some pretty simple math so that we don't have to punch this all out in a calculator, in which case we would probably get the wrong answer. You know, we might put in too many -7s or not enough, or get confused in our multiplication statement. So there's an easy way that we're going to deal with these, and that's what we're talking about today. The base of the product is -7. We can see that's the base in both of these. And the exponent, well, we've got two exponents right now. We've got a 3 and we've got a 5. But if we look at the final answer, now this person did put it into a multiplication statement. All right. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's -7 to the power of 8. All right. So the sum of the exponents in the power is 8. Sum, okay, is addition. Look at the number of -7s. There's 8 of them. But look at our original question. We've got a 3 here, and we've got a 5 there. Okay, so if we look at our exponents when it comes to multiplication, we get the right answer by adding them. So that makes it so much easier to find the answer in these. Instead of having to do all the multiplication down here and figure it out the long way, we could just look and say, well, if this is -7 and this is -7, and it's multiplication, all we need to do is add the two exponents. 3 plus 5 equals 8, and we can jump right to the final answer. Okay, so the final answer here is -7, and let's make sure we include the brackets here, and I probably should include them here because they are important, and to the power of 8. So we can just jump right from the original question right to the answer as long as we understand our exponent laws with regard to, in this case, product, which is multiplication. Okay, so remember, product is multiplication. Now this is just sort of taking care of the general case. A is any number except for 0. So it doesn't matter if it's 2, or 3, or 4, or 5. As long as it's the same here and here, okay, a to the power of m can be any number, and n can be any number. Okay, so let's just take an example over here. Let's just say that a equals 2, okay, and let's say m equals 3, and let's say that n equals 5. All right, if we were to have a question that said, okay, a to the m, so 2 to the 3, times, and I don't like the x, I like the dot, 2 to the 3 times, well, a is still 2, and n is 5. Okay, what that's saying is that's going to be 2, because that's a, to m plus n. So that's going to be 3 plus 5, which means our final answer is going to be 2 to the power of 8. So that's an example of what this means. Okay. Now dividing, okay, division is the inverse operation. Think of that as the opposite operation of multiplication. Well, in multiplication we used addition, so logically, for division, we're going to use the opposite of addition, which is subtraction. Okay, so exponent law with products of powers, products, is plus, and then with division, it's going to be minus. So we're going to subtract the powers, and I think you'll see how that works out when I just go through this example here. So if we're going to divide 8 to the power of 7 by 8 to the power of 4, okay, we can do all the math if we want, but instead of doing all this math, okay, why don't we just skip the whole process and go from here to here in one step using subtraction? Okay, so what we really can do, I mean, you can go through all this, and we know you can cancel from top to bottom and whatnot. You'll get the right answer. But if we know that the law with regarding to division is subtract the powers, we can go 8 okay, to the power of 7, divide by 8 to the power of 4, we could just take these two, because the 8's the same, and we can just do 7 minus 4 equals 3. Then we can just skip right to the answer. A to the power of 3. Okay? So why make it any more difficult than it needs to be? For multiplication, you're going to add the powers. For division, you're going to subtract the powers. All right, in this case, this is probably just going to reiterate what I just said. The base of the quotient is, that's the 8, correct? The exponent for the answer is 3. Okay, the difference is subtraction, of the exponents of the powers that were divided is 3. Just like we did above. Erase these little marks. All right, let's move on to the official explanation. Very similar to what we did for multiplication. Quotient is division, right? Okay, so for the quotient of powers, division, a to the m divided by a to the n equals a to the m minus n. Now let's just use the exact same example we did before. A is 2, m was 3, I believe, and n was 5. Okay, so if we do that, then what we've got is, okay, maybe I'll just put this over here. What we've got is a to the power of m, so that's 2 to the power of 3, okay? And then we've got divided by 2 to the power of 5. We're going to get a negative number on this one, that's okay, equals 2 to the power of m minus n. Okay, so that's the m, that's the n. Okay? So in this case, our final answer is going to be 2. 3 minus 5 is negative 2. It's going to be 2 to the negative 2. Now, we haven't dealt with negative exponents yet, so I'm not going to go too far into that, but the important part is that you get the right number up there. Okay, now let's write each expression as a power, knowing what we know about multiplication and division. Okay, so this one's multiplication. Let's keep that in mind. So for multiplication, it's going to be 6, and then we've got to add these to the power of 5 plus 4. So our final answer is 6 to the power of 9. Now, we don't need to actually find out what 6 to the power of 9 is. It just says write it as a power. So that's what we're doing. Remember, we can only do this if the bases are the same. In this case, the bases are both negative 9. Okay, so that's important. So you can always write the negative 9. Okay, so it's going to be negative 9. Okay, and then we've got 10. Now this time it's division, so we have to subtract 10 minus 6. So the final answer is negative 9 in brackets to the power of 10 minus 6 is 4. So you see, there's not a lot of math in this. Even though we could be dealing with big numbers, 6 to the power of 9 is a very big number. Punch it in your calculator if you don't believe me. 6 times 6 times 6 times 6, 9 of them, right? But if we're writing it as a power, it's just simple math. It was just addition. All right, on to the next one. We've got multiplication again. Okay, that's great. So, negative 2. That is the same base over here, negative 2. So let's just write that out. Negative 2. And then we've got multiplication. So we know we have to add the exponents. 4 plus 7. So our final answer is going to be negative 2 to the power of 11. Over here, we've got both multiplication and division. I'm not sure why that little dot's there. It's just been my finger or something. Okay. Multiplication and division. BEDMAS says if it's multiplication and division, we just go from left to right. If there's the same base, remember, we're always supposed to do exponents before we do a multiplication and division. But in this case, because it's all the same base, really we can kind of take care of it all at one step. So let's just write the base. So that equals 3. And then let's write all the exponents in the order from left to right. So it's going to be 2 minus, let's just do it in 2 steps. Okay, let's deal with this one first and that one second. So 3 to the power of 2 times 3 to the power of 4 is really just 3 to the 2 plus 4, because it's, oops, 4, not 3, because it's multiplication. So we know that we have to do addition for that one. Okay, to the power of 4. And then let's put the other part over here. Let's divide by 3 to the power of 3. Let's solve this one first, okay? So 3 to the power of 2 plus 4, that's just 3 to the 6, divide by 3 to the 3. Now that we've just got division, we don't need to subtract. So that equals 3 to the power of 6 minus 3. Exponent, exponent. 3 to the power of 6 minus 3 is 3. So that's your final answer there, is 3 to the power of 3. This final answer is negative 2 to the power of 11. Do a couple more. All right, now we've got addition and multiplication along with our exponents. We know we have to do the multiplication first, right? So, if it helps, you just put bracket around that so you remember to do it first. So let's leave the 6 squared for now because can't do anything with that yet. And now what we got is 6 to the 3 times 6 to the 2. So we know that's 6 to the 3 multiplication. So plus 2. 6 squared plus 6. 3 plus 2 is 5. So 6 to the 5. Okay. Now we can look at these numbers down here, and we actually have to do some math. We have to evaluate all this down. Because this is not multiplication, we can't just add these powers. It doesn't work that way. So we actually have to go to the math now. So 6 squared is 36. Okay? And 6 to the power of 5, I don't know off the top of my head. That's a big power, so I'm going to put it in my calculator. 6 times 6 times 6 times 6 times 6. Is that 5 of them? Is indeed. And the answer to that is 7,776. So 7,776. Okay, let's just add 36 to that. And we've got 7,812. So what's important about questions like this is that you recognize that as soon as you get a power plus another power, you can't do that addition trick anymore. It only works for multiplication and division. Well, multiplication for addition and subtraction for division. All right, let's look at the next one. We're just getting more complicated here. The base is negative 10, which helps us out, but then we got these brackets. And we got powers and subtraction and division and whatnot, one step at a time, right? We got to do what's inside the brackets first. So I'm just going to write the negative 10 to the power of 4 out front. Okay, now what's inside the brackets is negative 10 divided by, negative 10 to the 6 divided by negative 10 to the 4. Okay, so that's really just negative 10 to the power of 2, because we've got to subtract. So that'll be what ended up in the brackets, is negative 10 to the power of 2, right? 6 minus 4. And then we still got this minus 10 to the power of 7 at the end, okay? So now we're in a situation where we've got multiplication, right? There's multiplication right here, so we have to do that before the subtraction. So that's negative 10, and then we know with multiplication we can just add the powers. So that's negative 10 to the power of 6 minus 10 to the power of 7. Now it's important to note that the 7 is just touching the 10. It's not touching the negative and the 10. Okay, there's no brackets there. So now we've actually got to take this to our calculator. So same thing here, except, no, it isn't, sorry. This one should be in brackets still, because these negative 10s were in brackets and this one wasn't. So this is negative 10 to the power of 6. Because it's an even number, it's going to be a positive, okay? So 10 to the power of 6, remember when we're working with 10s, it's super easy, right? So it's just 10, or 1, sorry, with 6 zeros. 1, 2, 3, 4, 5, 6. Excellent. Now, for the subtraction, all right, the 10 is just hitting, or the 7, the exponent is just hitting the 10, it's not hitting the negative, so I got to keep the minus sign there. Now this one's 10 with 7, or 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, so now I just got to be very careful with this when I punch it in my calculator that I get the right number of zeros. So it's 1 with 1, 2, 3, 4, 5, 6 zeros. Subtract 1 with 1, 2, 3, 4, 5, 6, 7 zeros. We should get a negative number because this number is bigger than this number. So what we get is negative 9. 1, 2, 3, 4, 5, 6. Negative 9 million. Okay. Once again, when we got down to this part right here, we had to recognize we no longer had division or multiplication. So once we're down to the plus or the minus, we have to put it in our calculator, or in this case, because we know powers of 10 and negative 10 very well, we just have to compute it manually. There will be a different video for Exponent Laws 2, which is 2.5. Again, hopefully this is enough information for you to do the textbook questions. Don't forget the answers for the back of the text are also posted, and that you can email us with any questions that you have. Thank you.